Alright, this video is all about differential equations. So a differential equation is simply an equation that has an unknown function and one or more of its derivatives. So that equation could look a lot of different ways. As long as you have some unknown function y and one of its derivatives, then we have a differential equation. So here y plus x times y prime equals 2 is a differential equation. I have an unknown function y, one of its derivatives y prime. There could be a lot of different things going on. You could have something like the sine of y minus 2y double prime plus 3y prime equals 4. In that case, I have an unknown function y and a couple of its derivatives, y prime and y double prime. Okay, so those are just some examples of differential equations. Ones that we've examined before without really knowing it are ones of the form where y prime is by itself and then the right side of the equation is a function of x. So I have some function that we would call y, where it's a function of x, and I just said y prime equaled that. So for example, y prime equals x cubed. My function y is x cubed, and I have y prime equals that. So if I wanted to find the solution to this differential equation, all I would need to do in this case is take the antiderivative. So y would be 1/4 x to the 4th plus c. Now, what does that tell us? That tells us that our solution set to the differential equation is exactly that. It is a family of solutions, right? I don't just have one single answer. My answer is an equation that makes this true. And that any equation that makes that true, in this case, I have an infinite number of those. As long as I have some constant c, you know, c could be 0, c could be negative 1 million, it could be 0.125, whatever that happens to be, all of those are solutions to this differential equation. All right, so in general, solving a differential equation is not an easy task to do. So therefore, it's much easier to check to see if a function is a solution to a differential equation. So what we would do in that case is we're given some differential equation where I have an unknown function y and one of its derivatives y prime. Okay, so here's my differential equation. Instead of trying to solve this and say, hey, all of my solutions look like this. They all look like y equals 1/4 x to the 4th plus c, or whatever that would happen to be, right? Instead of saying that, what I'm going to do is I'm going to check to see if certain equations are solutions. So here we have y equals x minus x to the negative first. I want to check to see if that is a solution to this differential equation. So the first thing I want to look for is which derivatives of my equation do I need? Right? So I'm going to plug in the initial equation here, but I need its first derivative as well. Sometimes you may need the second derivative, the third derivative, whatever that happens to be. You need to find those equations first. So before I go plugging stuff in, I need to figure out what the first derivative of this equation is. So the first derivative of x minus x to the negative first would be, the derivative of x is 1. The derivative of x to the negative first, that's going to turn to plus x to the negative second, right? We multiply the negative 1 down, we subtract 1 from the exponent. Here's my derivative of that. Now, to simply see if this is a solution, I'm just going to start replacing things. So I have x times y prime. Well, y prime is 1 plus x to the negative second. And then plus y, well, y is x minus x to the negative first, right? That was my initial equation here, equals 2x. And the question is that true? Does that equal 2x? All right, so all I'm going to do is work through this and see if I get a true solution. I'm going to distribute my x. That would give me x plus x to the negative first, plus x minus x to the negative first. Does that equal 2x? My plus x to the negative first and minus x to the negative first would cancel each other out. I'm left with x plus x equals 2x. That's a true statement. And therefore, this is a solution. Now, I guess the question wasn't see if, it was show that. So I knew that was going to be a solution, and I've shown that through this process. But you may be asked just to check to see if something is a solution, in which case I do it the exact same way and then say, yep, that's a solution. I got a true statement at the end. If you do not get a true statement at the end, then it is clearly not a solution to your differential equation.